Greetings, everybody. Welcome to today's webinar, part of the Transforming Data into Digital Assets webinar series presented by PIMSoft. I am Ryan Boland, your moderator, and we thank you for joining us and hope you find this webinar informative and valuable. Today, we want to demonstrate PIMSoft's approach to reduce uncertainty in financial records, identify cost-saving opportunities, and address future requirements of the circular economy for fertilizer producers. In this webinar, you will learn how a model-based approach can validate and improve ERP data accuracy, how using cost allocation can identify high ROI projects, and how to extend mass balance infrastructure for the circular economy. Thank you for your attention. Now it's my great pleasure to introduce our presenter for today, Felicia Moody, PIMSoft's Industry Principal for Fertilizers. Felicia?
Hi, thanks Ryan for the introduction. Let me say thank you to everyone who's joining us just here today. This is our third webinar for the fertilizer industry, and it's a sincere pleasure to have you here. If it's a repeat, and for the new visitors, welcome. I'm going to try to touch three topics in this 30 minutes. One is getting your data ready for your business system. Okay, that's one thing, and we don't really like to talk about it. It's not so exciting, but it determines our future if we're still here years from now. We might have some engineers in the room, and we all have a daily job. We know we have to find projects, we have to reduce costs, we have to make more, we have to reduce the margins, and we need to find these locations, and we need to prove that we've done a good job when we've invested some money. And I want to also touch a little bit on the circular economy, how it could impact fertilizers. Not so far away, the legislation is already written, and there are companies that are already taking action within the fertilizer industry. So let's try to see if we can learn something together today. That's me, that's my contact detail. Reach out, I'm open to have conversations. So for those who don't know PIMSoft, this is our mission. We are in the business of generating value for our customers by improving the accuracy, reliability, and usability of their process and manufacturing data at all times across the enterprise. It's a mouthful, but it's what we do. We do more than data reconciliation. We condition the data, we make it accessible, usable, and we make it it's available to everybody in the enterprise as you want it. This is our story. We started, the PIMSoft is our product, PIMSoft is our company. Sigmafine started before the company PIMSoft. Okay, so Sigmafine started in 1993 with KBC, okay, in the US and UK. It was then acquired by OSIsoft, okay, who kept it until 2010. In 2010, PIMSoft bought the product from OSIsoft, and that's when Sigmafine became a property of PIMSoft. Okay, PIMSoft started in 1995, 2 years after the creation of Sigmafine. And here we are together. PIMSoft is the company, Sigmafine is the product. And we're growing. We have new offices in India. We acquired another company called Omicron, which is, let's say, the godfather of the process book. And we're growing, and we're here to grow with you. And let's see. Why do we do a mass balance? Like I said, I think there are three things I'm going to talk about today. One is getting your data ready, fit and ready for your financial records. One is to help engineers to identify and to track progress based on a cost allocation. And the other one is getting ready for the circular economy, which is knocking on the doorstep of fertilizer. Let's say for financial records, we know the primary thing, it's an operating requirement. It's like a license to operate. You cannot operate without providing quarterly records or annual records. It's the minimum. Inefficiency identification is why you do cost allocation. You want to know which assets are performing, underperforming, which product lines are costing too much. Should you continue? Should you change suppliers? And this is how you run your business, always optimizing cost at every level, from supplier to asset to technology to raw materials. And at the moment, let's say circular economy is at the national legislation level. We think it will come on two sides. In circular, we think you're going to see impact on, let's say, a stimulus to do it and also a penalty to not do it. Financial records, I highlight loss monitoring because it has happened. There's some significant use cases where the loss has also impacted your financial records. And I highlight inventory management here just to bring your memory to the previous webinar where we mentioned in how Sigmafine monitors your inventory. So if you missed those webinar, I suggest you to go to our website and take a look at how we address the inventory management within cost. That we did exactly a webinar on cost allocation for inventory management. Sigmafine mass balance. Okay, what is it? How do we do it? This is a very simple, a single balance point. You've got 5 measurements, 5 flows, and you've got 5 uncertainty values, okay, with these numbers. At the start of the situation, you've got a 10 imbalance, you've got an uncertainty of 5.9%. When the reconciliation is run, of course, the imbalance is gone, and almost, let's say, every reconciliation solution does that. But what we have built into the Sigmafine, it gives you an overall uncertainty. So here you can see not only is the imbalance gone, but now you know that your reconciled value is closer to the true. It's not as loose, let's say. So Sigmafine not only gets rid of your imbalance, but we give you a data quality. And this is provided for every measurement point and every balance point. Pay attention, please, that this is a very simplistic model. It has only 7 elements here. We have done Sigmafine implementation that has gone up to 10,000 elements. And we are able to do this calculation on a very short time frame. We've done it to as short as 15 minutes. So we've got teams of less than 4 people doing this kind of calculation for thousands of assets, in very short time. So that's why we're an infrastructure. What does it look like? A Sigmafine model, how does it do that? How do we get rid of the how do we reduce the uncertainty? We are not taking just your measurement data. We are connecting to more to your inventories, we're connecting to your planning and scheduling, we're connecting to everything, to your design data. And that's how we are able to reduce your data set. We're connecting it and making a homogeneous set. As you can see, remember from the previous slide, it starts with a model. We need to talk with the process engineers. We need to know where you are, and this is what it can look like. At each point, we're minimizing the errors, and we are pushing the data out. This is a standard refinery model. This is our demo. This is still a small system. Here we're talking about 250. This is less than 300 assets. This is just to give an idea that we have receipts. These are the inputs. They can be your financial data. Here you can see the data quality indicator on the global model. And for every measurement point, you have a measured and a reconciled value. And this mass balance, it can also be a volume balance, it can be energy balance, it can be mass and energy, it can be mass and component. This structure is the basis which we can apply many layers of analysis, which can even be automated. So we are here to support you in doing the balance, but doing it in an effective way and getting the data out so that it can be consumed for your financial and your cost accounting. So that's a bit of what the mass balance looks like in Sigmafine. It's graphical, but behind it, it is running the algorithm, and it is also giving you the statistical data indicators locally and globally. So in a nutshell, that's what Sigmafine, the mass balance context, looks like. When you do the mass balance, why do you do it? I mentioned in the beginning that we're doing it we're doing it once, but we're doing it to support two persons. We're doing it for the financial recording, which we know you're doing your financial accounting mainly to just show how profitable you are. That's what you have to show to the authorities, to your shareholders, to your stakeholders. On a day-to-day basis, you're monitoring your unit cost, how your assets are performing, how your suppliers are performing. Your financial system is always quarterly, minimum quarterly, annually, let's say, and maybe biannually as well. The engineers, the production people, they want to know daily, batch, monthly, and an event. If you have a big event, a failure of an equipment, you want to know how much material was lost. We can also balance on a time frame to map what happened in a particular time frame, an event. But both of them need to be systematic, auditable, and they are a representation of your financial data. On the right, I kept it as cost accounting, but it's basically it's the same color as Sigmafine, because this is what Sigmafine does. With the mass balance, you can apply cost tracking to do exactly what we're talking here. And it can be then aggregated from your daily, your batch, and your monthly to directly go to your quarterly and your annual reports. There are some other parameters to consider. Who are your consumers in your business, their shareholders and stakeholders? We're talking Sigmafine needs to connect to these guys. We need to send the data to the ERP, but we need to collect data from the process plan, from your planners, from your control systems. Yeah, we can do that. You are using, for the financial side, you're looking at your kind of tunnel vision. You're looking at your financial transactions. That's what the rules of the game dictates. In our cost accounting, Sigmafine does exactly that. It's taking both your fiscal data as well as your process data, as well as your estimates. So we can capture all forms of data from fiscal to online measurements to engineering estimates. Uh, Financial is historical. That's its function. It's that is tell what happened in the last quarter, in the last year, in the last 6 months. What we see now is that people want to know near real time how the assets are performing. Where am I today? Where am I this hour relative to last hour? And Sigmafine is able to do both this. It can approach near real time. I mentioned in previous slide, we've gone up to 20 minutes, 15 minutes. And we can also do the aggregation at the reporting level to get this data ready for your financial systems. I show you here a simple slide. It's a mosaic. It's a financial statements are public. This is an old one from 2013. Please pay attention to the inventory. Inventory here is 1.5 million, or maybe it's billion. Let's say it's million, but it's almost 50% of your cash. So fertilizer industries have a lot of inventory. Your process requires a lot of recycle, and it's probably the only data that is taken directly from your production records. So even though the production engineer and the plant managers are running and operating the plant to make money daily, to make good decisions, in the end, the inventory, which can be up to 50% of your cash, gets onto your balance sheet. And you don't want a number here with a 50% inaccuracy or 10% inaccuracy or uncertainty. So Sigmafine reduces the uncertainty in your inventories. I encourage you to look at our previous presentations and webinars for the fertilizer. You will see also a demo that we did at that one. More than other industries, when you have a big inventory, data reconciliation, applying your mass balance with your cost tracking can really reduce your uncertainty in that number. I'm going to show you here two use cases. They're a bit old. Maybe we remember Enron. It happened in 2001. Their share price fell from 90 to $1. I don't think it exists anymore. And it was cited as one of the largest American audit failures. Okay, so it was an energy company. It had some gas in it. And almost everything on the balance sheet was inaccurate, not just the inventory, not just the input and output, but also their debts and et cetera, et cetera. The problem with this case here is that they destroyed a lot of data. They destroyed process data, they destroyed financial data to reduce to, the less evidence, the less you can prosecute. So as a result of this very large loss, 63 billion, the Americans, they now have the SOX Act, the Sarbanes-Oxley Act. So this is a data monitoring and reporting quality. It's about the quality of the data. So in America, you need to report your statistical indicators. You need to prove that you have to have a system of record that says that your measurements, your data, not just your measurements, all your data is trustworthy, which goes to process data. So this has happened in America, and we have Sigmafine in place, not just to do the mass balance, but also to report the data quality, to send reports to satisfy this SOX Act. You would think that's the end of the story. Of course, it's not. 10 years later, a similar situation happened in Europe. Maybe you don't know about this one. It's Parmalat. And its share price fell from $3 to less than 10 cents. It's still around. We still see it in the supermarket. This one it's close to home because what was missing here is that the inventory, the assets were not real. So the inventory was missing. There was no real inventory, as well as probably some of the cash receivables. So This was a deliberate overestimation of inventory and current assets, and therefore the bonds that were sold to balance this asset, of course, had no value. In these both cases, the perpetrators were very high level people, and they were the ones that went to jail. So this is not a laughing matter. But in both of these cases, when you have a system of record, Sigmafine is a system of record. The data is trackable, it's auditable, you can do versioning. If something like this happens, when it happens, who did the action, it will be transparent. So perhaps it will happen. Okay. So that was just looking at the financial. And it's something we need to do, and if we do it in a good way, not only can we avoid these extreme situations, but we can help our day-to-day business. I did a quick research on, what are the low-lying fruits that's available to the fertilizer industry. If you were to put data reconciliation in now, if you did mass balance now on your plant, would you be able to find something? Okay, would you be? Okay. There is one study, all of these references are at the end of this presentation. It was focusing on the energy management aspect of fertilizer production, and it estimates that this study was done for European fertilizer production, that there is a 3 to 10% possibility to reduce your energy consumption, okay? Part of it is, one of the pillars is unitizing all of your consumption on each of your assets, your electricity, your power, your water, your steam, whatever you use. If you can see unit cost, each asset, not just what's flowing through the asset, but what it is using, you can see quickly in inefficiencies, and then you can start your maintenance. You can do capital projects to do systematic upgrade on the asset. It can pay for itself, etc. Another pillar of this 3%, 3 to 10% is material loss reduction. This one, they gave several cases of where these are leaks. These are not deliberate removal of material from the processing facility. These are just natural leaks that take place, and they normally have paybacks of less than several months. But you know more than I, finding a leak in a facility can be a very big job, okay? Another pillar of this energy management is steam loss. Just with steam alone, normally your steam projects have a payback of less than a year. And for those who use boilers and so forth, when you use, or in your furnaces, if you have something like that, if you can reduce your air, you can improve your efficiency. It's all about heat loss. The problem that I want to raise here is that if you have 10% reduction and it is divided into 4 areas, and within each area you have many assets, we're talking about fractions of a percentage. How can you find it? And how can you prove that you've done it? Your measurements are probably 3 to 5% accurate. Even with a plan like this, and you say, okay, I know I have some low-lying fruits, and these are my target areas. Sigmafine is a good infrastructure to do modeling, to do the balance with the hat on, to identify cost opportunities and to prove that it has been achieved. Case in point, this is show you how hard it is to find a leak, okay? So this happened not so long ago, 2016. Okay, you see how big this refinery is, how many tanks there are. Kind of hard. This theft took place for more than 2 years. They lost over about 2,000 tons, 2 to 3,000 tons of material. If you decide 2,000 tons by the daily production, all these volumes, it's pretty hard to do. And you see the total estimate. This was taken from an Emerson presentation. They are our partners. You can also see the full presentation of this if you visit our website. So this is a case where this is a deliberate loss of material. And it happens it can happen especially when you have connecting pipes. So the pipe it's of course you have it to supply, to guarantee continuous supply of material, but it's also a place where you can overpay or you can under-deliver. So this is why these pipelines, when material is crossing a boundary between one owner and another, you need a data reconciliation. You need something that is auditing this transaction, and it needs to be, let's say, taking in consideration data on both sides of the fence. Sigmafine has the capability to connect to a data source which is outside of your boundary via file, etc., via web-based solutions. So if something like this is happening, when you have an algorithm, a standard algorithm that is tracking, hopefully it doesn't take you 6 months, 2 years, sorry, to find out that 120 million of oil is stolen. Maybe you can see it in a couple of weeks that you're consistently under. You have to your statistical indicators have shifted from their normal. If the norm is 1 and it's 1.1, it's a big deal. Okay, maybe it was 10, it moves to 11. So what I'm saying here is that when you are monitoring not just the data but the quality of the data, you can detect events like these much quicker and probably can act as a deterring tool from perpetrators if they know there is a solution that is monitoring and balancing the data in a fair way. I want to bring quickly here, I mentioned it in a nutshell, what Sigmafine can do. Okay, Sigmafine today, we're talking about the mass, and we're balancing the mass, and I mentioned that on the mass balance, we can apply the cost tracking algorithm. Sigmafine has two arms, if you want to think about it. It can balance your data mass, volume, energy components. It can do double. And we can also track ownership. We can track source of the material. We can estimate. We call these the tracking algorithms. Sigmafine is an infrastructure. It has a very extensive connectivity capability. We can connect to many data sources, many historians. We can connect to IP21, etc. We can connect to your limbs. We can have manual data entry. We can go to the web. And another important pillar of Sigmafine is that it is traceable. So we have audit trails of all actions taken on the data. We have versioning, so when your process changes, it's always a model base, and you version, you put a new tank in, you update your model, you put a new version, your data set, so it is consistent. So we have traceability, and we can lock the data so that when the month is closed, the data is closed, and there are no changing when it leaves the production floor and when it goes to financial statements. Let's look to the future. Okay, so we looked at the past. We look what we have to do. We think we have an idea of what we could do now with the assets we have. What's the apple out there that we can get? We think it's between 3 and 10% just on the energy side. Now let's look to the future. This is again, the references are at the end. This is a picture of what let's say circular economy looks like at the moment. There is a part which is mechanical based, reusing metal scraps, etc. There is a chemical branch, which is, let's say, if you bring everything back to the energy content, okay, then you can talk about the recycling of energy, green versus recycled energy versus from the ground. And if you look to the left, we've got the green side, and this is where, we think for fertilizer might come in, mainly because you see farming. Maybe you're going to collect the runoff. Maybe you're going to get feed material from anaerobic digestion. Maybe they're going to do some chemical extraction of some waste. There is talk of, waste from the animal slaughtering house, that it's a rich source. So you can extract some N, some P, some K, and get it into the fertilizer. So there is even a wheel that is really targeting fertilizer because it's a big topic for the world population growth and feeding the world. So we're there. It's not just recycling plastic. It's not just recycling cars. Mechanical recycling is not only about chemical recycling, but it's also about the food chain. And why I brought it up today is let's think about money. Today it's a money discussion. In Europe, the study shows that 30% of our fertilizer can be replaced with recycled material. So what this study is saying, if we were to collect all the waste from food that's not eaten to all the waste from the animal slaughtering house, all the waste, the sewage, etc., 30% of all our fertilizer could be replaced. So it's a big market. The legislation is already being drafted, being proposed, already passed. At least in Europe, some targets are being set. They're considering some tax credits for the companies that go there and some penalties for those who are late to join the party. Of course, there are some challenges. It's not all about getting the IT infrastructure ready, you do have some process limitations. Your assets might not be able to produce process biomass as a source of nitrogen. You might need to put some physical assets in to be able to do that. To reuse recycled material, biological material needs to have some pretreatment. Need to have some disinfecting stages. And in Europe, there's the REACH regulation that is quite rigid on making sure that it's not contaminated. But 30% of a market is quite big. And if Europe is going there and you lose 30% of your market without participating, that's a big incentive to at least stay aware of what's happening. And I just to show you here, this was 2 years ago, 2000 and last year, 2019. For those who don't know Viola is it's a rubbish company. They collect rubbish. So a rubbish collecting company is now a partner to Yara, one of Europe's largest fertilizer producer. This is to propel the circular economy. So because Viola can potentially become, so Viola might be a competitor to, let's say, suppliers of N, to urea manufacturers. So be aware. It's happening, and if it's happening in the large players, chances are it's going to happen in other countries as well. Where does mass balance and material tracking come in? It comes in because it's still under discussion. How are you going to get credits for going green in fertilizer? They think maybe they're going to follow like DOP, original. You can certify that this is produced in a certain place, then it is as a DOP. Maybe some countries will decide they're going to do DOP fertilizer and it's going to be totally green. So if this fertilizer comes from Algeria, it is DOP. It's quite hard, but if it's done, Sigmafine can do the tracking of origin of material. Please, again, visit our website. Some people think that maybe that's not going to be enough. Maybe we are going to need to have a label. So many, a Yara, for example, might say we have a certain accreditation that we are green, etc. So this is many. So you can achieve this level of certification. Now you have fair trade. So fair trade doesn't mean the coffee came from Brazil or Jamaica. It just means that anybody who produces coffee in this particular way pays their workers, they've got good work conditions, it's fair trade, and they're fairly compensated. Maybe this will also come into place for green fertilizers. Again, here, this is all about labeling the material. We can track material boundary to boundary. We can track when it gets mixed, etc. with mixing rules. Again, please visit our previous webinars. We think that at one stage it could also be book and chain. So maybe some companies will, Yara might be the forerunner, and they might become they also sell raw materials to other blenders, let's say. So they might be selling some of their credits to monetize for those who are the first producers of green fertilizer. I remind you here, if you don't know, Sigmafine we have supported projects on the carbon credit trading system in Europe. So Sigmafine, we've already supported the data set to do book and chain in the energy side. And so we even have, you can visit our website from IPLOM. So whichever model is taken, and maybe each country will take something else. When you implement Sigmafine with a standard algorithm, we're not asking for any additional software. It can be configured to do any of these methodologies. That it will be one or a combination of these. Okay, so you will be ready for any methodology that is selected to disclose to your trading partners how green you are in your fertilizer, or how circular you are. This is the reference was done for fossil, but fossil just means a finite resource. In your case, of course, it is fossil for the nitrogen, but it can be P, it can be K. And essentially, you should be looking for a solution that can see your material, not just in terms of its content, but in terms of its property of how circular it is. And Sigmafine is able to do this on a mass balance as well as on a material tracking algorithm. I didn't show you Sigmafine a live demo here because we ran it in the first two webinars. If you want to see Sigmafine in fertilizer, please download our presentation or have a look. They're just 30 minutes, so you can watch them. This is to give an overview of what Sigmafine can do in terms of the context of today's talk. We can connect. Sigmafine can connect to your source data, your process data. Okay, the list is longer than what's here. We can push the data to your ERP system. We can also pull the data, okay, from your ERP systems. We can go to third party. If the pipeline is being sold by they can send us a file. We can grab this file, we can populate it, we can use it, we can send it back. We can have a meeting where we can say, this is your data, this is our reconciled data, we have a problem. We can also connect to planning and scheduling system. You can look at your target. Everything can be in one context. I mentioned the Sigmafine components. Here I'm confirming that we do mass, volume, energy component. We can do material tracking as well as quality tracking. For those, let's say the end producers here, we do have steam tables. We've got Penn-Robinson algorithms, so we can also do mass and energy balance, mainly on the inside of the fertilizer chain. I mentioned our automation. We've done smaller projects down to 15, 10 minutes, larger ones up to 15. We do have SQL access for the reporting, for Power BI. We go to the SQL, we open it up, and you can do your dashboarding. And operate. How does this bring you value? If you can connect to everywhere and you can do all these analysis, if you can do it very often near real time. Here I show you here that there are two good things about Sigmafine in context of circular economy and managing cost. Both local cost, cost accounting and financial, is the auditability. Everything is tracked, the versioning, the locking of the data. The actionability, apart from, you want to know when something is going wrong. Do you need to go search for it? No, you don't. We can push via email, we can push to web platforms, we can push to publishing, to reporting. We have online live dashboarding that you can see your assets, how they're performing. So in the background, yes, it is a model. Yes, it is engineering based, but you can go to actionability. So you can see your emails, you can see your dashboarding, and you don't see the model. So as an infrastructure that can support your data set that is used financially, that is used to run, to evaluate your projects before and after on a cost basis, and to support whatever kind of modeling, reporting requirements of a circular economy. Sigmafine is here to support you on all three fronts. So I really encourage you, if you don't have one, if you don't have Sigmafine, reach out to us. If you want to have a demo, please reach out to me. If you want to get more details on how we connect or use cases, this is a great opportunity. We are very open to meet you and to have a more detailed one-to-one discussion. That's it from my part.
Thank you for this great presentation, Felicia.
Okay.
A couple of questions queued up. The first one for you would be, what is needed to create model for the plant for mass balance?
Okay, so the mass balance, it's not the first step. The first step is we call it the functional design specification. So this is where we meet your stakeholders. Your stakeholders are your process engineers, your production planning people, your operations managers. So that we get an overview of where the data is coming from, who will be managing the data, where the data needs to go, what's the context. Is it for energy efficiency? Then we need mass and energy. Is it a black box approach just for ERP, just checking your boundaries? So when this phase is the most important phase. So the first meeting, we need a meeting from the planners to the schedulers to the managers, at least for a couple of hours, so we get the right context. And that is the first step and the most important step. And then we go into the details.
The next question that we had was just asking how to access the recording of the previous webinars. If you go to our website, if you go under the resources tab, there's a site there for webinar. I've also got the URL posted here. Do you have one more that came in? How can you tell how much of the product is recycled material?
Okay, so recycled material, for us, it's a property of the material. So this is our material tracking algorithm. So we can identify a material, for example, nitrogen, urea. We can say this is nitrogen from urea, and we can say it's nitrogen from biomass. Okay, so the algorithm that is the raw material which is being tracked is biomass. So in the previous webinar that we did, we showed that we could track, even though you had an inventory, which was a mixture of NPK 20, 20, 20, blah, 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 it was equivalent to urea, KCl, etc., P2O5. But also it's just because it is the name of the material. So just by giving a material property, which is its name, we can, when we run the mass balance, if you can imagine, on the mass balance, we know the material, the fraction of the material which is passing through. So Sigmafine sees it as a material. It doesn't say in the material tracking, it sees it as urea, and it sees it as biomass, and it sees it as P from P2O5 and P from bone meal. So it's from the labeling. And with the tracking algorithm, it does a continuity of this material labeling all the way through from beginning to the end to your inventory. So you can see your production, your products as equivalent raw material labels. So as well as your inventories. So you can see your inventory. Okay, I have 10 tons of inventory. How much of it is urea? How much of it is biomass? How much of it is P2O5 and ore, or how much is this P2O5 from meal? So it's all about the labeling of the material, and the algorithm does the rest for you. Please check out our webinar on the material tracking. It's quite nice.
Felicia, on behalf of all the participants and PIMSoft, we thank you for taking the time to participate in our webinar and share your knowledge.
Oh, sorry. So this, I don't know everything. So I give credit to the costing I took from a reference. The circular economy came from references. If you want to have some ideas on where this 30% of material is coming from, that bio-based fertilizer is a very good one. If you're interested in this topic, you can go to these. Each of them are about 200 pages, just so bear in mind it's a lot of reading. So I hope today that you see that with Sigmafine, you can do three things in one. We can support your data, especially the inventory that gets to your financial system. Sigmafine can be one of your main tools to make sure that data is really robust. It's not a fake number. And I think I showed you pretty clearly that when you are doing cost allocation, cost-based projects, and the numbers are very small, we're talking 0.5%, and your measurement accuracy is between 3 and 5%. It's hard to find what projects to take on, and it's hard to prove that you've done a good job. When you put the statistics on your data and you get rid of that noise and those bias, then you can see where to attack, and you can prove that you've done a good job because now you're working outside. This noise has been removed, and you can follow your steps really. And the circular economy is going to ask you to track not just the N and the P and the K, but where it came from. And the model in which it uses can be varied from book and trade to segregation, etc. But whichever model they choose to use, Sigmafine's tracking algorithm can support. And tracking is always a secondary algorithm to the mass balance, because first you need to get rid of that imbalance, and then you track the material. So Sigmafine is robust, and it's really fit for purpose for those who want to be ready for being able to create a data set that is compliant to support circular economy.
If there's anyone interested in continuing this discussion on mass balance, you can contact Felicia directly, the email provided.
Thank you.
Thank you once again. And there's also, if you go to our YouTube channel, you can see a lot of our past webinars and presentations from our Sigmafine Summit